Hi everyone, I'm Brendan. Recently we moved from a testing framework called Mocha to a new one called Jest, and hence the title. This was originally a very, very big presentation, and basically we can't cover all of that in this time. So what would BuzzFeed do? Make a listicle, of course. Yeah, so this is how much is left. But if you do want the full one, you can go to my blog, and I'll leave this up for a second. Okay, that's a second. This is a special edition for Node Meetup, the cut down version. What happened to ninjas? Exactly. Let's begin. All right, so what I want for all of you to take away from tonight is two things. What makes Jest different from the other testing frameworks or runners out there? And is it worth migrating from whatever you're using to Jest? And these are the various things that we will be talking about, except for the ones that are struck out. And if the demo gods favor me, there's going to be a demo as well. So first thing, so library versus framework. If you're using Mocha, or Jasmine or any of the other ones that were around before Jest came along, you will find this pattern pretty similar. You'll have a runner, which is the Mocha, and then you'd have pull in an assertion library, a mock library, a code coverage library, and then you didn't really have snapshots, but I guess you could also do them if you wanted to, but they weren't really integrated with the test runner itself. But with Jest, one tool does the entire lot. So that is basically a different paradigm. So testing tools, there used to be just a runner, and then everything else is bring your own, whereas Jest is batteries included. So just looking at this, we knew that we knew this up front, and then we were like, so is it actually worth it to put ourselves through the steep learning curve? Because if you switch to test runner, then you have to learn not just test runner, but all the things at once. And is it worth it, right? So the three things that we considered was that the front-end JS team had been frustrated with all the test runners they were using to test their React app, right? And they trialed Jest, and then they started raving about it. So I was like, that's interesting. Second thing was that we were writing a lot of tests that could otherwise be parametric. So basically stuff that you have the same test over and over again, but there's just one thing that changes in between them. We found ourselves writing the same test, copy paste, and then just change that one thing, right? And we heard about snapshots, and we thought, hey, that's got a huge potential to let us not do that anymore. So wanted to investigate that. And then I guess the last thing as well was that initially, we had the perception that Jest was only for front-end apps, and then at another Node meetup, Vasily, who is in the audience right here, gave a talk, and he said, hey, it works just fine in Node as well. So I was like, okay, ticks all the boxes, let's try this. That's Vasily.
Hello.
Would you like to say something? Oh, I thought you were raising your hand. All right. Okay, peace. Cool. So gotchas. There are actually a very large number of gotchas, and said presentation, the full one earlier, you can go check it out. But today I'm just going to highlight a couple of really interesting ones. First on the lot is that the assertion syntax can be quite different to that of Chai, which is, I guess, the most popular assertions library that you were using, or one would use together with Mocha, and certainly the one that we were using. You can see here that the syntax is different, and it's kind of a bit clunky. So this one is, if something is either null or undefined, and you want to check for that, but you don't care which one of null or undefined it is, then this is how you do it in each case. And the reason why I highlight this is that basically rewriting assertions is the single most time-consuming part of migrating from another framework to Jest. Yeah? I was not going to talk about it, but sure, since you mentioned it, there is a tool out there that called Jest Code Mods, which Vasily talked about. What I found was that that automates some of the process, and then you wound up having to manually do bits of it at the end, at least for our set of test cases. Yeah, so check out the full presentation online. Okay, cool. The next thing was that Jest has a file level sandbox. So this is a bit of a fundamental difference in the way that the test runner sets up, tears down the application. So with Mocha, you can have a single in-memory instance of the Node application, the server, and it just stays alive for the entire duration of the test run, but not with Jest. With Jest, what it does is each test file spins up a new copy of the server, right? And you will at some point have, and of course they also run in parallel as well, so that's another doozy. So therefore you need you wind up with all these many copies of server instances, and these aren't actually, if you have something to do with database or anything else with persistence in it, that can have side effects, and that can't be cleaned up or accounted for by sectioning of stuff in memory in different processes or whatever. But it also means that you have to be a bit more stringent about how you clean up from one test file to another. And we were getting a lot of non-deterministic failures because we didn't realize this. And then when we did, we figured out that, hey, this is what you do. So there is a way to specify a per test file cleanup and teardown. And you have to put it inside Jest config, and then, oops, right slide. Okay, so and then you inside that file you put in after roll, and then you do your teardown. Worth noting is that if your teardown takes a lot of the time, doing this per file also takes a lot of time and makes your test really slow, which it did in our case. So what we did was we just did the done callback to say that we're done, even though we're not actually done. Because it's sufficient to just start the process. Cool. So moving on, we have another common thing that you need to do in testing is to fake objects. Previously, we're using sign-on for this, and in Jest, this is how it looks. So you have jest.fn and then .mock implementation, and that will give you a mock of that particular function within the module. So in this case, my module original implementation of .foo is replaced by my mock impl, right? And then later on, you go and do your assertions using an expect, and it's pretty similar to those that you find in sign-on, right? So pretty easy, this part. However, with spies, we found that the Jest spies weren't quite as powerful as the ones in sign-on. And in particular, one of the irritating things was that you couldn't access the calls array as you can with mocks. So we found a workaround for this was to just use mocks and then put the original implementation back into the mock and effectively get a spy. Cool. So the next thing that you need to do with regards to faking stuff for tests is that servers don't typically just use info from your HTTP request or your database or any other persistence as the only inputs. They also use time as an input. So for example, if you're doing token cycling, you need to test whether the token is expired. How does the server know that? It looks at the global date object. And so because of this, fake the time in order for the test to be repeatable, right? Because if you don't fake the test, you'll have to wait for a long time before you can do your test, and also the results aren't exactly what they were the last time you ran them, so not a good situation. And to further complicate things, JavaScript has an event loop, and so you have to manage that as well. Now, with sign-on, you can just use it directly. They have a thing called, I forget what the API is, but then you get a clock object, and then you can just say clock.tick, and then that advances your date. Jest doesn't have that, not that I know of, and it also doesn't play well with sign-on's built-in thing. So we just found a single-purpose library called mockdate, but there's several out there, and just plugged that in. Yeah. So then the other part of the equation is the event loops, and there are two queues, and I wasn't even aware of the distinction as far as testing was concerned, at least, between these two. But as part of learning Jest, I've found that you actually can control these two different macro and micro task queues separately, and in fact with Jest you're kind of forced to, right? So that loop is effectively what how the normal JavaScript event loop works. This is not the detailed version. The real one has got about 20 lines of nested statements just in pseudocode to describe what it does, but I think this is a pretty simplified version of it. And with Jest, you actually get to, it basically mocks both of these queues, and so anything that enters either of these task queues do not get executed unless you run Jest functions. So in this case, with the macro task, you have to do this particular call, and then you run to a particular time. So set timeouts and friends, that's how you do it. And then with other things like promises that with then and catch, and process.nextTick, they also they are micro tasks, and then you have to run them through this other Jest API called run all ticks instead. Yeah. So I guess a big picture thing is that if you're using sign-on, which you just use the same API clock.tick to a particular time, and then the date gets advanced, the micro tasks get run, the macro tasks get run. Actually, I think I swapped the columns around. Sorry about that. So it should be macro in the middle and micro at the side. So with Jest, you have to use another library to advance the date, the global date object, and then you have to call these two different functions to advance these two separate queues. So you get to manipulate these aspects separately, but it's also more tedious. So more granular control versus extra lines of test code, I suppose. So now some fun stuff. So bullet points aren't going to really do any of this stuff any justice, right? So just very quickly, watch is a way to run Jest in always on mode, and just sits there, and it keeps rerunning the tests whenever you save them. And you can also filter for a particular test and skip the rest. Coverage is, I guess, not really a Jest thing, but it's cool that you don't actually have to set up Istanbul or any other thing and sort of like fudge it and stick it into your test runner. Like, it just is all totally integrated, and that's pretty awesome. Snapshots is a new feature which we'll go into later, but essentially you can auto-generate your test expectations, and then I'll talk about how you can kind of do TDD-ish with that, test-driven development. And also snapshots have an impact on how much code gets repeated in your test cases. So demo time. So this is the business logic of the application. Fairly simple. You have a light bulb, and it is connected to two switches. So I have one of these at home. If you enter the corridor, the light switch is either up or down. It doesn't matter. When you push it, it'll just flick to the opposite state of what it is currently. And that circuit diagram kind of describes how it works, but we're going to try and implement that. And that GitHub repo was done in earnest, but it's not up yet, so don't check yet. Check later. Okay, cool. So, and also the other thing, I've only got to the create switch API. I haven't really done the flicking bits yet, so not so fun. But it's good enough to show Jest in action. And next, a prayer to the demo gods while I find a way to drag the terminal onto screen. Oh, it's there already. I need to make that big. Is that big enough for everyone? Cool. All right. And let me find the code editor. All right, cool. So I've created a fairly simple API there is a Swagger definition that defines, not this one, sorry. There's a Swagger definition that defines if you do hit this URL with these parameters that have to be numbers, then you create a multi-way switch. And then you can either get a new light state or an error response. A light state contains a light, hang on, where is it? Oops, sorry, it's not even on screen, my bad. Sorry, so this is the Swagger file. So you hit that API, those are your query parameters, and then right at the bottom, your response can either be an error, or you can have a light ID, a light state, and switch states. Light can be either on or off, the switches can be up or down. So essentially, that's what we are creating. So firstly, I've written a test, right? And so it just hits that API with a valid query parameters, and then it does this, expects that the error doesn't exist, and it also grabs the status of the response as well as the JSON body of the response, and then it does .toMatch snapshot, which is the snapshot functionality that I've been talking about. So what I'll do is I'll go to snapshots and I'll delete the current snapshot. Actually, before I do that, you can just take a look at it quickly. So this is what a generated snapshot looks like. You can see before I was, so that was a test case that you just saw, right? So essentially it adds an export, and the string is essentially the full name of the test case plus a number. If you have more than one snapshot, then you'll see something other than one. And then whatever was inside the expect. So in this case, the body as well as the status. So I'll delete that file. This is a bit tricky since I'm not mirroring. Cool. So now let's run the test. So I've set up an NPM script for tests, and then I've added an additional couple of parameters for watch and coverage. So run that. Demo gods. Sorry? The deleted file. Damn it. Literally just ran it. What did I do?
Yeah, the map is still there.
All right, let's save it. Literally.
You deleted something that is not Mac.
That is not Mac.
It's not Snapshot. Yeah.
Oh. What did I delete? Oh, that's not good. I didn't even use a Git repo for this. Let me. Yeah, that's a good point. Let me find my trash can.
Yeah, probably server test framework setup.
That is a good point. Put back. All right, let's try that. Okay, cool. Demo gods. Yeah, okay, so we've got a coverage report in summary form over here, which we will take a look at properly later. And over here, we've got test expectation failure, right? Okay, so let's actually delete that, the snapshot file. Better get the right one this time. Delete. All right, move to trash. All right, now let's run that again. So I'm going to hit Q to quit and then run the same command. Okay, so now it's running in watch mode, and it only has, so because I deleted the snapshot file, it literally just generated the snapshot, right? So you'll notice that previously, even though there was a problem with my thing, right, it actually passes. So this is one of the things I wanted to highlight, actually. There is a huge pitfall with snapshots in that because it's automatically generated, it's quite easy to write incorrect assertions, right? So as you just seen. So over here previously, if I Command F, not the result I wanted. I'll find it manually. Persist. And okay, there we go. So over here, I have a fix me over here saying, okay, so here I'm creating two light switches that are I guess both up, but I've gone and put down instead. So let's fix that, right? And over here, you'll see that the test cases are now failing with the same result as before. So what I can do here is one of two things. And so this comes to the whole TDD thing. So you can write your test first and just write .to match snapshot. And so long as your endpoint is there and doesn't crash while trying to do something, you will get some sort of response which you can serialize into a snapshot. And then you just have to decide whether that snapshot is correct or not. So right now we've decided that we've got an incorrect snapshot. And we can either do what I just did, which was fix the implementation and then get a new snapshot and then press U, which is in the prompt here, right? So it says U to update failing snapshots under watch usage. Or alternatively, I could just go back to just the snapshot file that was generated, and I can change the expectation over here. So in this case, I'm just going to be lazy and say, hey, I'm just going to update the snapshots. So now if I were to run the test all over again, it'll pass. And this time it is passing, but it's not giving me a false positive. So yeah, that's important. Now, apart from this test coverage over here, which is actually under hood running Istanbul as well, this is just a summarized form. You can see each file, how many % of each type of coverage category you're seeing. You can also generate a report. Let's find that over there. Okay, so over here we have, just refresh that. And over here you can see under multi-way switch API, I have some test coverage problems. So I'm going to ignore that one for now and look at the one that we just looked at. So we can see over here that the bits that are highlighted in red, they're essentially telling me this line of code or this statement or branch is not getting hit. And so therefore either your application has dead code or the application or the tests are insufficient. So in this case, I think this error checking code here is correct. It should be there, but the test cases are insufficient. So let's go and fix that. Right. So we'll go to the test over here, and I've previously already written this test over here. Cover error cases, and okay, cool. So now we've got a slightly better scenario where we have test cases where we have a number of switches that isn't valid according to one validation rule. And over here, we have a light ID that is occupying the same space as the light that was previously created. So I'm just going to save this file now, and you'll see that this test runner, which was running in the background in watch mode, just reran. And if now you'll see instead of one test case, we have 3, which is great. 2 new snapshots have been written, so that's very important to go and manually inspect the snapshots, make sure that they're right. I won't do that for now, but what I will do is I'll take a look at the coverage reports. So this is the before, and I'll just open a new tab so that you can see the difference, and we can see over here the same file, right? So these 2 bits were red, these 2 bits are not red anymore, right? So we still got, light with this ID already exists. I wonder what's going on there. Aha, there is another problem. So over here, we have got this test case. The code coverage is indicating that it is being hit. But over here, we have a thing that we say should not create a new light because the ID has conflict, but it doesn't seem to have hit that point of code. So something is wrong. Let's take a look at the snapshots, right? And we see over here that ID has conflict, the test case. It actually created the same light ID. So this light ID 1 has been created twice. Something doesn't make sense. So this obviously was a stages example. The reason why I highlight that is because I said, hey, I'm going to skip checking the snapshots. Boom. Don't do that. Because you can get funky shit like this happening. So I guess double way to check. One is you check your code coverage, and one is you check your snapshots. And if both of them say you're right, then you probably are right. Yeah, okay, so let's go and fix that. So since I have cheated and basically made a problem for myself, I've realized that, hey, actually this is the problem. So over here in my store, I wasn't going drill down to entity and then set the entity. I was doing like drill down to the entity but then set on something else. So I'm not going to do that anymore. Now I'll save that, and in the background, boom. So now I'm getting a test failure, right? So in this case, you'll see that the stored snapshot is failing because it's expecting that should not create a new light, has a conflict, expects a new light to actually be created, but now it is getting a test result that's saying, hey, there's actually an error, status 400, because your light ID already exists. So then we're like, okay, so the snapshot's telling me that something's gone wrong. Which of the two is correct? Do I go fix my application, or do I say, hey, now the updated snapshot is correct? So in this case, I know that I need to update my snapshots. Quite easily done. Just hit U and it's done. So one snapshot updated. Let's go check that that's been done. And over here, where is it actually? Yeah. So the conflict one now expects there to be an error. Yeah, so that's, is there anything? Oh, there was one more thing I wanted to show, which was parametric tests, right? Over here I have a parametric test, and what I mean by that is the ability to basically create a for loop and have just one thing that changes within the loop, and then you just get a whole bunch of test cases for free. So previously, if I were to have done this, I would have either had to copy and paste this entire it block multiple times and then change the value of light ID and num switches by hand in each one. So everything, all the other lines were the same except for this value. Or I would use a for loop, but then the for loop inside here, I will have to like sort of mimic the application logic, right? So in this case, it's kind of contrived, like the application logic is literally just spitting the same number back out at you. But in more complex cases, you wind up putting more and more of the application logic and mimicking that in your test cases just so that you can get them into this parametric state. And I consider that to be an anti-pattern. So what's even better is if you can just do this and you can have Jest automatically generate all of the test cases, the parametric test cases, which have now magically just appeared over here. And you know, like that way, if you do change your test cases somehow, then you'll just get a snapshot update, and then you can just review, as you said before, is this an application change error and I need to fix my application, or is the expectation change? So it really, this whole snapshot feature combined with Watch was like, I guess, a bit of a mind-blowing experience. Like in theory, it sounds great, but then when you actually do it, it's just like, I am actually saving so much more time. I am so much more productive writing tests. And yeah, so let's go back to, that's the end of the demo. All right, back to slides. So I prepared two slides, one for demo okay and one demo not okay. So yes, demo okay. Okay, so as a quick summary, I'd say that, like I just said, the watch mode is awesome when you combine it with coverage. and also when you combine it with snapshots. As you just saw earlier, when you write test code, when you write application code, one of the software engineering principles that you strive for is dry, do not repeat yourself, right? And with test cases, dry is kind of an anti-pattern when you start pulling in or copying application logic within your test cases. So then you start doing damp, which is like neither dry nor wet. It's, you know, just somewhere in between, and it kind of doesn't feel right because there's no cool acronym for that to stand, and other such irritating things. Anyway, so snapshots enable that to be done quite smoothly, as you've just seen. The other thing as well is test-driven development. You saw how I wrote the test case first, and then went and fixed the implementation that was, you know, missing or incomplete. Yeah, so that's great. So I made a meme for this. Yeah, should have put that up earlier. The big question, is Jest worth it? So is migrating from another test runner worth it? Is learning all the new things like a test runner, a assertions library, a mock library, time manipulation, snapshots, all of these things, learning them all upfront, it's a big upfront investment. Is it worth it? So this is what I'd say. For new and existing projects that are simple, totally worth it. For complex projects, on the other hand, not so much, right? So as awesome as the stuff that you saw just now is, if you already have a huge code base with a lot of tests and a lot of coverage, and it can become very tricky to migrate. And there are tools, such as Jest code mods, that can automate the conversion pretty well, but then there's still those last few edge cases that you'll have to write, and those ones tend to take the most time, especially if you didn't do the migration by hand in the first place. So yeah, so you wind up doing quite a few things by hand. So if you don't have a lot of time to invest in your sprints or whatever it is for coverage, one of the approaches that we've been taking is to migrate bit by bit. So any parts of the application that we're modifying, or any new parts of the application, new features that we're building, then we write the test in Jest, and the old mocha tests, they're still there, and we just get rid of them as they're replaced, or we just leave them intact. And hopefully at some point of time, it'll slowly transition all from mocha to Jest, and that's like the grand plan. But there's no rush, because what we can do is we can just run both test runners one after the other, and then basically it feeds into our CI via JUnit report, and we just use some XML smooshing to put them together, and then you get one nice big test report. So do it piecemeal, in summary. Questions?